Hello, I'm Lawrence here at Project Heaven. We're back in the engine room. And you might have seen a previous video we were talking about the 205 T16 rally car. And I mentioned that we're going to be supercharging it with this Rotrex supercharger. I'll talk a little bit today about some of the options we could have had to us. The types of supercharger at very least, and turbocharger as well. Why the customer chose supercharging and why we opted for the Rotrex in the case of this engine build. So none of these superchargers or turbochargers are particularly well suited to this application. The engine is very much smaller than some of what these machines would be suited to, but they do work well to illustrate how they work. As you can see, some of them are fairly old as well. So on the left here we've got some supercharger options. So as I'm sure you know, the purpose here is to put in more air than the engine would swallow if it wasn't supercharged. This is a 2-litre engine. Each of those cylinders is half a litre. And if the air filled the cylinder completely, that'd be half a litre of air. But of course, if you force it in with any of these different types of supercharger, you'll get a whole lot more air in there. And of course, then you can burn more fuel and make more power, which is the idea. So these are all air pumps, or air compressors, if you like, and they're all forcing air into the engine. We'll start here with a very typical supercharger. This is a positive displacement supercharger. This one has 3 lobes. They interact with each other. In fact, here's a really good way. Why don't we start with this one? We'll come back to that. These are the lobes, and they rotate typically on top of the engine. You might see something this shape on top of a V8 engine. So this is obviously a little bit of an old, tired supercharger. Here we go. There we go. We can see them rotating next to each other. Now the air, you can see they interact. Yeah, there we go, with each other like that. So the air can't come through this gap in the middle. The air enters in the top here, and it goes into this cavity. And as these rotors rotate, you can see now the air that did go in through there is now trapped in this chamber as it passes around the outside of the supercharger. And then as it continues around, we're now 180 degrees around, the air that came in here is now down here. And there's another gap at the bottom there, a hole for the air to go into the engine. So that's the air's done a journey around that lobe there. And the same is also happening on this side. So the air goes in, passes around, and is then forced into the engine. Now, if this air pocket was the same size as the engine's capacity, we've achieved nothing. But of course, you can spin this machine faster than the engine, or the size of the supercharger would typically be bigger than the engine, so you can force in more air than you would otherwise have got. So this is a twin lobe supercharger, as you can see. There's 2 lobes on each rotor, 1, 2 here, 1, 2 here. This is a 3 lobe supercharger. It's a little more difficult to see, but essentially it's a star shape with 3 lobes here, here and here, and they interact with each other. The beauty of this one, those rotors are not straight like they are in this supercharger. They're twisted. There's a sort of a corkscrew arrangement. So they interact in the same way. The air still goes in here, goes around the outside and down into the engine. Same on this side. So you can see the screw shape as they interact. This is slightly less powerful than the first supercharger I showed you, for the same size, if you like. This is obviously much bigger, but if they were the same size, this is a slightly less powerful design. But the advantage here is you get a smooth air delivery. There's no pulsing because there's this, because of the screw effect. You never get to a point where the rotors get to the outlet and suddenly they open and the air pulses in. So this produces pulses of air. This produces a nice smooth flow. Both of these types, this one is the same as this, in fact, but it's in one piece. I've taken this one apart for the purposes of having a look inside. So all of these types are driven off the engine simply with a pulley on the front here, and it's rotated a lot like our Rotrex supercharger here with a pulley. So that's supercharging, engine-driven air compression basically. And then of course, as I'm sure a lot of you know, these are a selection of turbochargers. We've got a little Ford turbocharger here. This is very typical of sort of a 2-litre engine, increasing the power by a small percentage. Probably very efficient, probably fast to react, because there's very little spinning mass, and probably very much mass produced. This is a Garret M24, much more of a performance car turbo. This is a pretty big turbocharger. I'm not certain what this one was used for, but it's fairly common, the Garret M24. I'm not certain which car it came off, but I mean, this might be 300 or 400 horsepower turbocharger. And then we've got a much bigger here, a Holset turbocharger, which is off a large diesel engine. So this can obviously deliver a huge amount of air. So with the turbocharger, there's massive efficiency gains to be had, because you're driving the supercharger, which is this side of it, compressing air into the engine. You're driving that using a turbine from the exhaust. So while you do increase the back pressure of your exhaust, because you're having to force the exhaust through here, this collects energy not only from pressure but also from temperature. So you are getting the energy from the temperature is free, if you like. The energy from the pressure drop does offer a restriction to the engine, but the energy you're gaining from the temperature drop across this turbocharger is free energy. So these are obviously more efficient. Of course, you get the disadvantage now. When you accelerate, it takes a little amount of time for the turbocharger to spin up and generate that boost, whereas a supercharger is always ready to go. It's spinning all the time. So this brings me on to the Rotrex supercharger, and I'll talk a little bit about why we selected this for the 205 T16 build. You can see this looks very much like these turbochargers. If I take these caps off, it actually operates in just the same way as the compressor side of the turbocharger. So you can see inside it's just like a turbocharger. I'm not going to rotate it. There's many warning messages saying don't rotate it. But of course this one is driven from the engine, which is why it gets a supercharger name rather than the turbocharger. So the reason we've gone with this is because for the T16 build, we're asking for more than double the power, really. So the pressure ratio of the turbocharger needs to be 2, or just a little greater than 2, doubling the pressure. A lot of the Roots type superchargers that were available to us, typically the Eaton, the M62, maybe the M92, they can generate a pressure ratio of 2, but they're really beyond the very efficient region of their compressor map. They're operating too outside of the parameters that they were designed to operate. The supercharger is not operating efficiently. There's a lot of heat being generated, so that's wasting energy. It's taking energy from the engine to drive that supercharger and produce that heat you don't want. And then of course you've got more heat to get rid of, so more intercooling to do. So we looked at many different options because these do suit the engine so well, delivering lots of air at any RPM. They just increase that torque curve linearly across the rev range. They're really wonderful in that respect, but to get a pressure ratio of 2 and up to 2.2, they really were outside of their optimum operating range. The Rotrex then, because of this arrangement, it generates more boost at higher RPM. The faster this supercharger spins, the more boost you can achieve, whereas these achieve the same boost at any RPM. So at very low RPM, this is doing nothing. And at very high RPM, it might be producing more boost than you need, or more boost than the engine can handle. So that is the compromise of these. But of course the advantage is it's very compact, as you can see comparing these two. These are large superchargers, but this is a very compact supercharger. And it's also very efficient compared to these older supercharger types. So this might have been very well suited to aviation, in fact, where you have your engine sat at a certain RPM. But where you're using your engine through a very large RPM range, this has that slight disadvantage. But there are ways around it, of course. We might need to dump pressure at extremely high RPM. And of course, it's a reasonably highly tuned engine, even without the supercharger. The other thing you can do, of course, is get your gear ratios nice and close. So this car actually has a 6-speed sequential gearbox. So the drop in RPM between gear changes is very minimal. The engine is always at a very high RPM. And of course, that suits this supercharger because it's always producing good boost. So this was chosen because, well, it's compact, which will help, of course, but it's going to efficiently produce that pressure ratio in the region of 2, or just a little over 2 times atmospheric pressure. So I hope you enjoyed our little talk about superchargers and turbochargers, and more specifically why we've chosen this interesting Rotrex type for the Peugeot 205 T16 Group B rally car replica build. If you've got a similar project, or a car of any age really, going way back, or a more 80s car, or even a modern car which you need something doing something like this, then you can call Project Heaven.